Hello everyone, myself Hans. Today we are going to solve the problem of UPSC 2024 from topic the cylinder. Here in the question, find the equation of the right circular cylinder which passes through the circle x square plus y square plus z square is equal to 9 and x minus y plus z is equal to 3. Let's solve the problem. Given a sphere is x square plus y square plus z square is equal to 9. That is equation 1. And the plane is x minus y plus z is equal to 3. Let this equation 2. Sphere, given a sphere with center is 0, 0, 0 and the radius is 3, and here the plane given from plane 2 we have to find direction ratio that is coefficient of x is 1 and coefficient of y is minus of 1 and coefficient of z is 1. This is the direction ratio of the given plane. Further we have to solve. Let beta and gamma be the point on the cylinder, then the equation of generator is x minus of alpha upon direction ratio is x minus alpha upon 1 and y minus of beta upon minus 1 and z minus gamma upon 1. Let this is equal to lambda. We know the following formula, that is x minus alpha upon L and y minus beta upon m and z minus of gamma upon n. Here L, M and be the direction ratio we have to find from the given plane 2. Further we have to solve. We have to find the value of x, y, z from the equation of generator, that is x minus alpha upon 1 is equal to lambda, and from here we have to write that is x is equal to alpha plus lambda, and for y that is y minus of beta is upon minus 1 is equal to lambda, and from here we have to write y is equal to minus 1 is cross multiplication with lambda, that is plus of beta minus of lambda, and further we have to find the value of z, that is z minus gamma upon 1 is equal to lambda, that is from here z is equal to gamma plus lambda. We have to put the value of x, y, z and z in the given equation 1 and 2 to satisfy the equation. We have to put putting the value of x, y and z in equation first and second. We get, first we have to put in equation 1 that in place of x we have to put alpha plus lambda, that is alpha plus lambda का whole square and place of y we have to put beta minus lambda, that is beta minus lambda ka whole square, and in place of z we have to put gamma plus lambda, that is gamma plus lambda ka whole square is equal to 9. This is equation. Let this equation third. Further we have to put the value of x, y and z in equation 2, that is in place of x we have to put alpha plus lambda, and minus of in place of y we have to put beta minus lambda, and in place of z we have to put gamma plus lambda is equal to 3. Let this equation fourth. We have to solve equation third. Equation third solving, that is on open alpha plus lambda ka whole square, that is alpha square plus lambda square, alpha square plus lambda square plus of 2 alpha lambda, and plus of we have to expand beta minus lambda ka whole square, that is beta ka square plus lambda square minus of 2 beta lambda. Further we have to expand gamma plus lambda ka whole square, that is gamma square plus lambda square and plus of 2 gamma lambda is equal to 9. From here we can also write, that is alpha square, and we have to take plus beta square and plus alpha square beta square plus of gamma square, and further we have to take alpha beta gamma, and we have to take 2 once again lambda square and lambda square, 1 2 3 plus of 3 lambda square plus of 3 lambda square and minus of 2 alpha lambda and minus of 2 beta lambda plus of 2 alpha lambda and minus of 2 beta lambda and plus of 2 gamma lambda, taking in one bracket, that is taking 2 lambda common, that is from here alpha and from here is minus of beta and from here is plus of gamma is equal to 9. Further we have to solve we can write equation fifth. Further we have to solve equation fourth. Equation fourth solving, that is alpha plus lambda and minus of beta and plus of lambda and plus of gamma and plus of lambda is equal to 3. We have to further solve from here, that is alpha minus of beta and plus of gamma and lambda 1 2 plus 3 lambda is equal to 3. We have to find it from here, that is 3 lambda is equal to 3 and alpha minus of beta and plus of gamma taken into right hand side, that is minus of alpha and plus of beta and minus of gamma. Once again, 3 lambda is equal to 3 minus of alpha plus of beta and minus of gamma. From here we have to find the value of lambda. It is lambda is equal to 1 by 3 and 3 minus of alpha plus beta and minus of gamma. We have to put the value of lambda in equation 5th. We have to put the value of lambda into equation 5th, that is alpha square plus beta square from equation 5th. Alpha square plus beta square plus of gamma square and plus of 3. We have to put the value of lambda, and the value of lambda is 1 by 3. Lambda square is, that is 1 by 9 and 3 minus alpha plus of beta minus of gamma ka whole square. Further we have to put plus of 2 and again put the value of lambda here, that is 1 by 3 bracket 3 minus of alpha plus beta and minus of gamma, and here is already present bracket alpha minus of beta and plus of gamma is equal to 9. Further we have to solve. Further we have to solve, that is alpha square plus beta square plus gamma square, and from here is 3 is 9, that is 1 by 3 plus of 1 by 3 and 3 minus of alpha plus beta and minus of gamma ka whole square, and from here it is 2 by 3 and bracket 3 minus of alpha and plus of beta minus of gamma into alpha minus beta plus of gamma is equal to 9. Further we have to solve 3 minus of alpha plus beta, alpha minus beta. We have to take from here, that is alpha square plus beta square plus gamma square, plus from here we have to take common 1 by 3 3 minus of alpha plus beta and minus of gamma, then the remaining is, here is 3 minus of alpha plus beta and minus of gamma, and here is 1 by 3 is common, that is plus of 2 and alpha minus beta plus gamma is equal to 9. Further we have to solve taking LCM, that is 3 alpha square and plus of 3 beta square plus of 3 gamma square and plus of 3 minus alpha plus beta minus of gamma is in bracket. We have to from here, that is 3 minus of alpha 3 minus of alpha plus beta minus of gamma and plus of 2 alpha minus of 2 beta and plus of 2 gamma is equal to, here is 9 3s are, once again when taking LCM, in the denominator we have also 3, so 3 is cross multiplication with 9, that is 27, and from here we can also write 3 alpha square plus of 3 beta square plus 3 gamma square plus of 3 minus alpha plus beta and minus of gamma, and from here we have to solve the bracket, that is minus of alpha and plus of 2 alpha, that is plus of alpha and plus of beta and minus of 2 beta, minus of 2 beta, that is minus of beta and minus of gamma and plus of 2 gamma, that is plus of gamma and plus of 3 is present is equal to 27. We have to multiply with this function, that is 3 minus of alpha, multiply with, that is 3 alpha square plus 3 beta square plus 3 gamma square plus, we have to multiply with the equation, that is 3 into alpha is 3 alpha and minus of 3 beta and plus of 3 gamma and plus of 9. Further we have to multiply minus alpha with the following, that is minus of alpha square and minus of alpha square and plus of alpha beta plus of alpha beta plus of alpha beta minus alpha square and minus of, once again minus of alpha square and minus of alpha beta plus of alpha beta and minus of alpha gamma and minus of 3 alpha. Further we have to multiply with beta, that is plus of alpha beta and minus of beta square and plus of beta gamma and plus of 3 beta. Further we have to multiply with minus gamma with this function, that is minus of alpha gamma and plus of beta gamma and minus of gamma square and minus of 3 gamma is equal to 27. From here we have to also write, that is 3 alpha square plus 3 beta square plus 3 gamma square, and from here that is 3 alpha and 3 alpha, and where is alpha? We can take 3 alpha, 3 beta. Here is plus of 3 alpha and minus of 3 alpha is cancelled out, and minus of 3 beta and plus of 3 beta is also cancelled out, and plus of 3 gamma, once again 3 gamma and minus of 3 gamma is also cancelled out, and the remaining is minus of alpha square plus of alpha beta and minus of alpha beta. We have to further write, that is minus of alpha square minus of beta square, once again minus of alpha square minus of beta square and minus of gamma square, minus of alpha square, minus of beta square, minus of gamma square. Further we have to write that is alpha beta and alpha beta, that is plus of 2 alpha beta and plus of, one second, alpha beta, plus of alpha beta and plus of 2 alpha beta and minus of alpha gamma and minus of alpha gamma, that is minus plus, that is 2 alpha gamma. Further we have to solve plus of beta gamma and plus of beta gamma, that is 2 times of beta gamma, and here is 9, one second, 9, here is 9 taking into right side, that is 77 minus of 9. Then we have to write that is 3 alpha square minus of alpha square, it is 2 alpha square and 3 beta square minus of beta square, that is plus of 2 beta square and plus of 3 gamma square minus of gamma square, it is plus of 2 gamma square. And from here we have to take 2 common, plus of 2 common, that is alpha beta minus of alpha gamma and plus of beta gamma is equal to 27 minus 9, that is 18. And from here taking 2 common from left hand side, that is taking 2 common from left hand side, that is 2 common, that is alpha square plus of beta square plus of gamma square and plus of alpha beta and minus of alpha gamma and plus of beta gamma is equal to 18. And 2 is taken into denominator of 18 and directly we have to cancel out 2 9s are 18. We can also write that is alpha square plus beta square plus gamma square plus of alpha beta minus of alpha gamma plus of beta gamma, and 9 is taken into left hand side, that is minus of 9 is equal to 0. Hence the locus, that is alpha, beta and gamma, is replaced by x, y and z. Then we have to write that is x square plus of y square plus of z square and plus of xy and minus of x z and plus of yz minus of 9 is equal to 0. This is the required equation of the right circular cylinder which passes through the given circle. Thank you class and thank you for watching.